In this video, we're gonna talk about the chapter 4.5, problem 7. Consider the function fx equals to, as I show in the picture. So we need to find the critical point and find out the increasing or decreasing and the concave up and concave down at each interval. So first of all, we need to find the critical point, which is A. When x equals A, that will be the critical point. So to find the critical point, we need to use the first derivative. So first of all, we need to find the derivative of fx, which is that will equals to we can just change this equation into a fraction form. That will be easier for us to do for the calculation. So to find the critical point, we just need to let the first derivative equal to 0. Then it will be equals to 0. So as it's shown, we just need to let this part equals to 0. So that will equals to just let x minus 5 equal to 0. In that way, we can easily know that the x will be 5. So to verify that when x equals to 5, it is a critical point, because when x equals to 5, the derivative will equals to 6 over O. And we can know that doesn't make sense. So the derivative at the x equals to 5 do not exist. So this is just proof that the x equals to 5 is the critical point. So we already know the A. So the A will be 5. On the next, we need to find the increasing and decreasing of each interval that divided by the A. So there are actually two parts. First part is x, in the negative infinity to the A, which is 5. So we can just find a value inside that interval. We're gonna plug in x equals to 1 and do a first derivative test, and it will equals to approximately negative 3.779. So because of this is a negative sign, so we can know that is at this interval the graph of the equation is decreasing. On the second interval, which is 5 to the positive infinity, we just same as the first one, we just plug in the value inside that interval. So at this point, we're gonna plug in x equals to 10. And the derivative of x equals to 10 will approximately equals to this. So because of this is a positive number, because have a positive sign, so we can know that and inside this interval, the graph is increasing. So we already know that this is decreasing and this is increasing. On the second part, we need to figure out the concave up or concave down. So we need to find the second derivative to figure out the concave direction. So first of all, we need to calculate the second derivative of fx, which is we can do a further simplify. It will equals to same as the question that we did before. Still just plug in the value inside that interval. So when x in the interval of negative infinity to 5, we can know that fx has the negative sign. When it's on another interval, the fx will also have a negative sign. So we can know that all of those intervals all have a concave down, because of the second derivative of x is all smaller than 0. So we can know that it's concave down and concave down.